All right, welcome to Unit 4 lesson. There we go, 14. And so in this lesson, we're going to be talking about a different type of function called an absolute value function. And so an absolute value function is represented by the distance, right? Absolute value represents the absolute value of a number is a distance from 0 on a number line. And so I'm going to show you a couple examples of what that looks like, but we are talking about our absolute distance from 0. And so if this is helpful for you as you're going through, draw a number line on your piece of paper and kind of count each of the spaces as you're going through. And so let's talk about our first situation. So function A gives a distance x from 0 on a number line. It is written as absolute value with two straight lines. And so this is what an absolute value function looks like. A of x is equal to 2 bars and an x in the middle. That is what we represent absolute value. And so I want you to first complete the table, and we're going to sketch a value of a function of h. And we have two different rules here. Andre represents our first one, which is our piecewise representation of a absolute value function. Elena represents a absolute value of a function. And so this is what an absolute value function looks like. And so it is the 2 bars with the x or whatever input variable you have in between. And so let's take a look at what that looks like. And so we have our table first and we have our sketch. And so first one's first, my input is 8. We are starting at 0. How many spaces away is 8? And so as you saw, 8 is 8 spaces away from 8. And so I'm plotting this on the graph. We have the plot 0, 8. Sorry, we have the plot 8, comma 8, right? We have the point 8, comma 8. And so very simply, what if I'm talking about negative 5.6? And so when I have a negative value, right, we're still at negative 5.6. And so that still tells me what? I am zero point 0.6 over 1, 2, 3, 4, 5. And so my distance is 5.6 spaces away from 0. Distance is always measured in positive numbers. And so be very, very careful when you're doing this. Our absolute value functions, when we're talking about our distance, it represents a positive number. So anything that's negative becomes positive. Because think about even with elevation, right? I'm measuring this much high is a positive number. And when you're measuring a lower number, you're not saying that it's a negative value. You're just saying it's a below ground level. And so it is 50 feet below ground. And so distance doesn't give you a negative value, right? If you're going backwards, you're still going in amount of distance. You're just going behind your start. So it's not a negative value, it's just before your value. And so, come on. Distance will always, always, always be positive from our 0 number line. And so we plot our second point, right? Negative 5.6 and a positive 5.6. So I want you to take the time now and fill out the rest of your table. And so a very big hint, if you need to Google what pi is 3.14. And so pi is a positive number, so pi is the same distance as it is from 0. And so I want you to complete the table and sketch a graph. I want you to connect all your values together, and I want you to tell me what shape it's going to give you. Afterwards, I want you to explain how both equations, and I told you about the first equation, represents Elena's equation represents an actual absolute value equation. And I want you to tell me how Andre's, which is a piecewise function, which we did last time, also represents, excuse me, my function of A. And so here are the graphs and equations that represent 5 absolute value functions. And I want you to tell me what is going on here. We will notice that these aren't the same, right? They're all a little bit different. They all have a 2 somewhere in their relationship. And I want you to notice that number 2 appears in equations for functions g, h, j, and k, all in different places. Some are positive, some are negative. And I want you to describe how the addition or subtraction of 2 affects the graph of each equation. Then think about the possible explanation for the position in the graph. How can you show that it really belongs to where it is on the coordinate plane? So our original f of x, when x is -1, f of x is +1. When f of x is 0, we have a positive 0 and obviously positive or negative 0, but x is positive 1, f of x is equal to negative 1. This is a common one that we were looking at before. G of x is a little bit different. We have g of x minus 2. And so what we notice here, if I subtract 2 from x, right, inside my absolute value, the graph moves to the right by 2 units, right? Do you see how the middle of the graph is here, my vertex, right? We call this a vertex of the graph. My vertex of graph here is 0, 0. Here, when I subtract 2, I'm moving the graph to the right by 2 units. And you can see that using the table as well, right? When I take that negative 1 and I subtract it by 2 gives you negative 3. And that negative 3 is going to give you a positive 3, right? That's that value here. That's that point here. At 0, 0 minus 2 is going to give me absolute value of negative 2, which is going to be a positive 2, which is here. And my absolute value of 1 minus 2 is going to give me negative 1. And so I have an absolute value of 1. So all my points just shifted over to the right. And so if you create a table, you can kind of see this a little bit more clear. And so if I'm subtracting 2 from x, it moves the graph to the right by 2 units. And you could take a look at what's happening with, so everything's being shifted over by 2. And if you take a look at the graph and table of H, what is happening when I add 2 from 2x? How does that move the graph? Are we moving left or right, up or down, and how much am I moving by? So take a look at your graph, take a look at your table, and tell me what you describe. On the other side of it, I also have an equation, a graph that represents when I'm subtracting outside or adding or subtracting outside the absolute value. And so with function j, I am subtracting 2 from absolute value of x, from my entire absolute value of x. And in this case, we can see that the graph moves down 2 units, right? So my vertex, instead of being here, right, my outputs change. My output is changing here. So instead of going left or right, I'm moving up or down. And you can see that in your graph, right? So when negative 1 here is a positive 1, right? We see that in this point here. But in this case, negative 1 has a value of negative 1 here. So I'm taking that point and I'm shifting it down 2 units, right? We took that 1 and I shifted it down 2 units. I took that 0 from here, right? That 0 from here, and I shifted it down 2 units. I took that 1 from here and I shifted it down 2 units. And so you're taking that output value and you're shifting it down 2 units. And so subtracting 2 from absolute value of x moves the graph down by 2 units. What happens when I add 2? What happens to the function k? So I want you to describe and tell me what is happening to the function of k. Alrighty, so using what we just went over, I want you to take your 5 equations here and I want you to match them to different graphs. So here are 5 equations and 4 graphs. And so I want you to match each equation that represents it. One of the equations does not have a match. For the equation that does not have a match, I want you to create a table and sketch the graph on the blank coordinate plane. And you can use Desmos to double check your answers as well. So I'll provide a link for you in the homework as well to hopefully help you. But remember, take a look at what's going on. If you're ever stuck, make a table, right? This is telling me I'm shifting my graph. If I'm subtracting here, I'm shifting my graph 3 units to the right. And so take a look closely to your graph. Okay, I'm shifting it from 0 to 3. So I know that equation 1 is letter B here because I'm shifting my original equation over 3 units to the right. And so go through each scenario and tell me what is represented here and how you can describe each of your values, each of your equations using graphs. And so we'll be going over this in class together as well. And so that is it. Take a look at the learning targets. Describe the effects of adding a number to an expression. Describe the meaning of an absolute value. And you can, given an absolute value function notation in words or in function notation, you can create a table and a graph to represent it. And so I look forward to going through with you in class.